We continue with section 3B, putting numbers in perspective, and we'll do problems 5, 6, 7, and 8 in this video. Problem 5 is a lot like the problems that we've done in chapter 2. How many liters of oil are required to supply the electrical energy needs of an average home for a month? So let's look at some of the details that are given. The annual average electricity consumption per US household in 2013 was 10,908 kilowatt hours. We'll calculate the energy in joules, which means our first step is to convert the annual consumption from kilowatt hours to watt hours. Once we've converted kilowatt hours to watt hours, our units change to watt hours. The watts can be changed to joules per second. And once we change the hours to seconds, we can get our answer after all the units cancel in joules. And this is very close to the final answer. All we have to do now is figure out how many liters of oil we need to produce this amount of joules energy. So let's go through the steps. Our first step is 10,908 kilowatt hours changes to 10,908 times 1,000 watt hours. So combining the numbers, we get 10,908,000 watt hours. And once we have our units in watt hours, remember the hyphen for watts is for watt hours. The hyphen in between the watts and hours translates to times. It's the same as saying it's 1 watt times 1 hour. So in the second step, we do two things. We change the watts to joules per second and the hours to seconds. So once that is done, the seconds and the seconds get canceled. We combine all the numbers to get 3.92688 times 10 to the 10 joules, because joules is the only units left. Now finally, we want to figure out how many liters of oil we need to release 3.92688 times 10 to the 10 joules. So we use dimensional analysis to solve this problem. So we take the joule quantity, multiply it with 1 liter over 12 times 10 to the 6th power joules. So why we do this is to be able to cancel the joules and the joules, and that way we have liters left in the numerator, and that gives us the amount of liters of oil that we need to produce 3.92688 times 10 to the 10 joules. So doing all the calculations using a calculator, that is the quantity that we get. 3,272.4 liters of oil is needed. Now we look at the next problem. So first we need to figure out what a scale ratio is. A scale ratio of 1 to 10,000 would mean that the actual distance is 10,000 times the map distance. So we could be talking about the scale on a map. Now, a lot of times the scale on a map is described this way. 1 inch equals 10 miles. So 1 inch on the map translates to 10 miles real or actual distance. Now, when the units in which this relationship is expressed are different, it is not easy to say that the real distance is so many times the map distance unless the units are exactly the same. So, for example, we cannot say that the real distance is 10 times the map distance because that is not true since the units are different. So, let's first standardize the units. So, we're going to change miles to inches. The way we go about doing that is go in two steps, change miles to feet and feet to inches. The equations that we're going to use are these two. 1 mile is 5,280 feet, and 1 foot is equal to 12 inches. So 10 miles, so 10 miles over 1 times 5,280 feet over 1 mile times 12 inches over 1 foot. So the feet and the feet get cancelled. The miles and the miles get cancelled. And our final answer is in inches. It's 10 times 5,280 times 12 inches, which is the same as 633,600 inches. So now we can say that, let's look at this equation. 1 inch on the map is the same as 633,600 inches on the actual or real value. Now that the units are standard on both sides, the scale ratio can be described as 1 to 633,600, which is the same as saying that the actual distance is 633,600 times the map distance. So let's look at the next problem. There are approximately 2.2 million marriages per year in US. Now, it's really hard to imagine this large scale of numbers, 2.2 million marriages per year. Now, maybe it'll make a little more sense to us if we express this quantity in marriages per hour. It might just make sense. Let's just think about this. 2.2 million marriages per year is the same as 2.2 times 10 to the 6. 10 to the 6 is a million marriages per 1 year. So the word per translates to division by 1 year. Now we're going to change years to hours. We're going to leave this number alone, 2.2 times 10 to the 6 per 1 year. 1 year is 365 days, and that's how we cancel the years. 365 days, but now we have days left in the denominator. We need to cancel that out and change everything to hours. So we have 1 day is equal to 24 hours. So we know that. We change years to days and days to hours. So 1 year equals 365 days. The next equation we use is 1 day equals 24 hours. So using the two equations, we're able to cancel the days and the years, and we have units of time being hours in the denominator. Simplifying all the numbers, entering it into your calculator, you get 251 marriages per 1 hour. So this is a little easier to grasp. It's like 1 hour, there are 251 marriages happening. It makes a little more sense than 2.2 million marriages per year. That is a little harder to imagine. So this is basically what we're doing. What we're doing is putting numbers in perspective, putting it in a way that makes a little more sense to us. So the next problem, in 2014, 136.78 billion gallons of gasoline were consumed in the United States. For every gasoline, there is a gallon of gasoline burned by an automobile, approximately 10.2 kilograms of carbon dioxide is released. Now, we need to estimate the total amount of carbon dioxide added to the atmosphere by the automobile travel in the United States over a year. So this is the annual usage of gasoline in gallons, 136.78 times 10 to the 9 gallons. 10.2 kilograms of carbon dioxide produced per 1 gallon of gasoline. So the gallons cancel out, and what we're left with is kilograms of carbon dioxide. So simplifying all the numbers, this is the amount of carbon dioxide produced annually by automobile travel in the United States. Now, notice here that we're getting some information. I'm not checking whether it's valid or not. We're just doing the math based on the numbers that we are given.